Now we can see the chapter triangle. In the previous class we have discussed the basic proportionality theorem, or it is also called a Thales theorem, and its converse theorem. Now in this class we can see the problems related to basic proportionality theorem. Now we can see the question 1. If a line intersects AB and AC of a triangle ABC at D and E respectively and is parallel to BC, then we prove that AD by AB is equal to AE by AC. We try to understand the question through the diagram. Given that if a line AB and AC of a triangle ABC, AB and AC of a triangle ABC at D and E respectively, it intersects respectively, and this line and is parallel to BC means that line DE is parallel to BC, then we prove that AD by AB is equal to AE by AC. So we can see the answer or the proof. We have given that DE is parallel to BC, it is given. Therefore once a line drawn parallel to any one side of the triangle, then it divides the other two sides proportionally. This we have discussed in the basic proportionality theorem. According to that theorem, AD by DB is equal to AE by EC, since by basic proportionality theorem. Now we can take the reciprocal of this ratio, that is DB by AD is equal to EC by AE. Now adding 1 to both the sides, that means adding 1 to the ratios is called the component rule. Therefore DB by AD plus 1 is equal to EC by AE plus 1. DB plus 1. Here we can take the LCM 1 by 1 and 1 by 1. Multiply here AD and here also AD, so that we get DB plus AD whole divided by AD. Here into EC and into EC. EC plus AE is EC plus AE divided by AE. Now we can see in the diagram, that is DB plus AD is AB and AE plus EC is AC. So that DB plus AD is AB by AD, the denominator is same, is equal to EC plus AE is AC divided by AE. Or we have already taken the reciprocal in the we have to keep the answer in the standard form only. So once again the reciprocal. So AD by AB, here AD by AB is equal to AE by EC, AE by EC. This result is called the corollary of the basic proportionality theorem, and we can use this in solving the problems. Now question number 2. ABCD is a trapezium with the AB parallel to DC. Here we have given the ABCD is a trapezium with the AB line is a parallel to DC. E and F are points. Here E and F are the points on the sides AD and BC respectively, such that EF, another side, EF is parallel to AB. We have to show that AE by ED is equal to BF by FC. Now we see the answer. Let us join AC to intersect at G. We join A and C to intersect EF at the point G here. And we have given that AB is parallel to DC and EF is parallel to AB. Therefore, EF is parallel to DC also, because lines parallel to the same lines. AB is parallel to EF and AB is parallel to EF and AB is parallel to DC. Therefore, EF is parallel to DC also, since lines parallel to the same line are parallel to each other. Now in the triangle ADC, we consider the triangle ADC. Here EG parallel to DC we consider, because EF is parallel to DC, its a part is also a parallel. So EG parallel to DC. When in a triangle ADC, EG parallel to DC, then apply the Pythagoras theorem here. Therefore AE by ED is equal to AG by GC here, since by basic proportionality theorem take it as 1. Similarly, from triangle CAB or ABC, here GF is parallel to AB as EF is parallel to AB, hence its part is also a parallel. Then so CG by AG is equal to CF by BF. Now, or we can take the reciprocal AG by CG. In equation 1 it is AG by CG. So compared to that, we take the reciprocal of this. AG by CG is equal to BF by CF. Now in equation 1, AG by CG is equal to AE by ED, and in equation 2, AG by CG is equal to BF by CF. Therefore, from equation 1 and 2, AE by ED is equal to BF by CF. Hence the answer. Now we can see the question number 3. In the figure, PS by SQ is equal to PT by TR or RT, and angle PST is equal to angle PRQ. These two angles are equal. Angle PST is equal to angle PRQ. We have to prove that triangle PQR is an isosceles triangle. Isosceles triangle means in a triangle, if any two sides are equal, then they are isosceles triangle. Now we can see the answer. It is given that PS by SQ is equal to PT by TR. So if a line divides the any two sides of the triangle in the same ratio, then that line is parallel to the third side. This is what? This is the converse of the basic proportionality theorem, and hence according to converse of the basic proportionality theorem, here PS by SQ is equal to PT by RT. Hence ST is parallel to QR. Take it as a 1. But therefore, once a line is parallel, then their corresponding angles are equal. So angle PST is equal to angle PQR, because ST is parallel to QR. Therefore, their corresponding angles, angle PST is equal to angle PQR. Take it as equation 2. But we have given that angle PST is equal to angle PRQ. Therefore, angle PQR is equal to angle PRQ. Therefore, angle PQR is equal to angle PRQ. That means in a triangle PQR, these two angles are equal. If these two angles are equal, the side opposite to equal angles are also equal. Therefore, side opposite to angle R is PQ, side opposite to angle Q is PR. Angle Q and R are equal. Hence, PQ is equal to PR. Therefore, PQ is equal to PR. Since side opposite equal angles are equal, therefore if any two sides are equal in a triangle, then that triangle is isosceles. Therefore here triangle PQR is isosceles. Next question, number 4. E and F are points on the sides PQ and PR respectively of a triangle PQR. For each of the following cases, state whether this line EF is parallel to QR or not. So we have given that P in the first case, PE is equal to 3.9 centimeter and EQ is equal to 3 centimeter, PF is equal to 3.6 centimeter, FR is equal to 2.4 centimeter. Now try to solve the first problem. In the triangle PQR, first we find the ratio PE by EQ. PE is equal to 3.9 and EQ is equal to 3, that is equal to 1.3. Now PF by FR is equal to 3.6 divided by 2.4, that is equal to 36 by 24, that is equal to 3 by 2 is 1.5. Since the ratio PE by EQ is not equal to PF by FR, therefore this line PEF is not parallel to QR. Now we can see the second problem here, that is PE is equal to 4 and QE is equal to 4.5, PF is equal to 8 centimeter, FR is equal to 9 centimeter. Again find out the same ratio how we solved in the question number 1, that is PE by EQ. PE length is 4 centimeter is given, EQ length is 4.5 is given. Find the ratio which is 8 by 9, and PF by FR, that is PF by FR is equal to 8 by 9. Hence the PF by FR and PE by EQ ratios are same. Therefore if the ratios are same, then that line is parallel to the another side. Therefore EF is parallel to QR here. Next question, number 5. In the figure, LM is parallel to BC and LN is parallel to CD. We prove that AM by AB is equal to AN by AD. Now see here, in the triangle ABC, now we can consider this triangle ABC. Here it is given that LM is parallel to BC. We use the basic proportionality theorem. Therefore, here we can, here AM by AB is equal to AL by AC. We used here corollary of the basic proportionality theorem. Both here the ratio, the sides are the sides of a triangle AML and ABC. This uses by the corollary. Take it as 1. Now in the triangle ADC, given that LN is parallel to CD, here LN is parallel to CD, then AN by AD is equal to AL by AC. Also we used here corollary of the basic proportionality theorem. Therefore from equation 1 is AL by AC is equal to AM by AB, and here AL by AC is equal to AN by AD. Hence AM by AB is equal to AN by AD. Next, question number 6. In the figure, DE is a parallel to AC and DF is a parallel to AE. Again you can see DE is parallel to AC and DF is parallel to AE. By using this, we have to prove BF by FE. Here BF by FE is equal to BE by EC. See the answer in a triangle ABC. This we can consider in a triangle ABC. Don't consider this DF and AE, only DE and AC. In a triangle ABC, DE parallel to AC. Therefore, here BD by DA is equal to BE by EC. Using basic proportionality theorem, take it as 1. Next, in a triangle BAE. Here in a triangle BAE, you consider only DF is parallel to AE. Don't consider DE. Only DF is parallel to AE. Then BD by DA is equal to BF by FE. Since basic proportionality theorem. Here BAE is the triangle. Don't consider this DE. DF is parallel to AE. Apply basic proportionality theorem so that we get BD by DA. Here BD by DA is equal to BF by FE. Now in the equation 1, BD by DA is equal to BE by EC, and in 2, BD by DA is equal to BF by FE. Therefore BE by EC is equal to BF by FE, since from 1 and 2. Next, question number 7. In the figure DE, here DE parallel to OQ and DF parallel to OR. Show that EF is parallel to QR. In triangle POQ, where is triangle POQ? Here, triangle POQ, DE parallel to OQ. DE parallel to OQ, since it is given, if a line drawn parallel to one side of the triangle, it divides the other sides proportionally. Therefore, PE by EQ is equal to PD by DO, since B.P.T. take it as 1. In a triangle POR, here DF is parallel to OR, that is, therefore, PF by FR is equal to PD by DO. Take it as equation 2. From 1 and 2, both PD by DO and PD by DO is equal to PE by EQ and PF by FR. Therefore, PE by EQ is equal to PF by FR. PE by EQ is equal to PF by FR. These are the sides of a triangle PQR. They are in the same ratio. Hence, that line is parallel to the third side. That is, EF is parallel to QR. Since we used here the converse of basic proportionality theorem. Question number 8. ABCD is a trapezium. ABCD is a trapezium here, in which AB is parallel to DC and its diagonals AB and this AC and BD are the diagonals intersect each other at the point O. We show that AO by BO, AO by BO is equal to CO by DO. Now draw a line. Now we need the construction to prove this. We draw a line EF through the point O such that how we draw should become parallel to CD. That is, EF is parallel to DC or CD. In the triangle ADC, now we consider the triangle ADC, this triangle. Here EO is parallel to DC as EF is parallel to DC. So EO is a parallel to DC here or CD. Then AE by ED is equal to AO by OC. Take it as 1. Now in a triangle ABD, OF is parallel to AB. OF is parallel to, or again EO is parallel to AB here. Then AE by ED is equal to BO by DO. Therefore, here AE by ED is equal to AO by OC and AE by ED is equal to BO by DO. Therefore, from 1 and 2, AO by OC is equal to BO by DO. But we want to prove here AO by BO is equal to CO by DO. Hence, interchange here this. So, this will come here and this will go to here. So, AO by BO is equal to OC by DO. Hence, the problems.